Hi, so in this video we're going to be going over the AQA GCSE additional physics topic of resultant force. So if you think about an object, you will understand that there may be several forces acting on it all at the same time, such as a ball rolling down a hill has the force of gravity bringing it down the hill, but it may have other forces such as the wind blowing it in different directions. Or you could also think about a tennis ball. That is affected by the wind at the same time after being hit and the force of the bat hitting the ball. So I've drawn a little diagram here to show. We've got a moving object with loads of different tiny forces acting on it all at the same time. And essentially, resultant force is when you add all of these different forces together, what comes out is one single force which is driving it in a particular direction. So although the ball rolling down the hill has lots of different forces acting on it, it still just moves in one direction. So the resultant force is when you add all of these different forces together, so you get one unifying resultant force which moves the object in one direction. Zero resultant force is a different concept. So when all of these forces acting together are balanced, the resultant force is zero. So let's go back to this diagram and say all of these green and blue forces were the same value. So we were to add, we would consider the green value as positive values and the blue values as negative values. So let's say that it was positive 1, 2 and 3, add negative 1, 2 and 3. Well, you get plus 3 plus negative 3, and we know that when we have a plus and a minus sign, it becomes a minus sign, so the resultant force is 0. So when all the forces acting on an object are balanced, the resultant force is 0, and this is known as the zero resultant force. And essentially, the way you think about zero resultant force is you have to think about what the object was doing before it got zero resultant force. So with a stationary object, if it has zero resultant force, it will remain stationary. So if we have left a weight on the floor, for example, the force of gravity pulling it down is balanced by the force of the ground pushing it back up. And so it doesn't move because its resultant force is 0. And with a moving object, the resultant force, when it is 0, will mean that it will remain at a constant speed. So say the ball was already moving when all these forces became balanced, it would continue to move but at the same speed as before. Now we can talk about non-zero resultant force. And essentially, this is when all of the forces acting on the object are not balanced. So what I was talking about first, when you have a ball rolling down the hill, if these positive values were greater than the blue negative values, then it would have a non-zero resultant force. And this essentially means lots of different things depending on the situation. So I'm going to use a different example now, that of a seesaw. So one of the outcomes, well, if you have a stationary seesaw and you get a non-zero resultant force, it begins to move. So as I said, when you had a stationary object with 0 resultant force, it wasn't moving at all. If this resultant force becomes non-zero, then it will start to move in the direction of the resultant force. So let's look at an example. Here we have a seesaw which is stationary because it only has one weight, and the weight of the object pushing down is balanced by the weight of the ground pushing it back up. So its resultant force is 0. Say we were to put a weight on the other side, it would move down. So the new resultant force, which is the weight of the blue moving down, making the resultant force unbalanced, means that it begins to move in the direction of the new force, which is where I placed this object. But there are other alternatives that can happen if the object was already moving. So let's still think about our seesaw. If it was moving to begin with, two different outcomes can occur. So it can start to move faster if, for example, in this example, we have our object moving it up from the ground, our new object being placed on the seesaw, and it begins to move.
Yeah.
If we then, while it's moving, place another object, it will start to move even faster. Or it will accelerate, which is something we'll talk about in another video. It can also change direction. So let's go back to this example. It's beginning to move down because of this object, but if we were to place an object on the other side, it will change direction because the weights are unbalanced. And these all happen when it has non-zero resultant force. I hope this video helped. Thank you.